So there's the arc length formula. If you try to apply it to the whole circle, you plug in 2 pi for theta. And if you did, what you'd have is 2 pi r, which is the correct formula for the circumference of the circle, for the whole circle. That's so you can check to make sure you have the right formula. Now, moving on, we're talking about speed now. And you have linear speed, and this is already on your notes. You have linear speed, which is this distance per unit time. And in our case, we're talking about distance traveled around a circle, but that's just how you do speed all the time, right? Then angular speed is how much you rotate per unit time. Now, let's go ahead and write this down somewhere, because now this one is distance per time. This is angle per time. What relates the distance to the angle? S to theta. S equals what times theta? Right. So watch this. I want to rewrite this. So I could say that's r times theta, couldn't I? But I could also rewrite it like this. Let me see. I could pull the r out separate. I can do that. But what is this? Isn't that your angular speed? And, oh, by the way, that is not a W. It's a Greek letter omega. It's a lowercase omega, just for the record. And so, you know, it's kind of curly. It definitely goes like this, I think. Anyway, it's not a big deal. But that's usually what we can do, is that right there, to find the linear speed. Let's do the first example. And this time, I went too fast, my last period, so I'm going to give you time to read the problem, okay? See if you can catch my mistakes. First period, I just made the mistake. They caught it, that was good. Second period, I made the mistake on purpose, and they didn't catch it, which is sad. Now you have forewarning, so you better catch my mistakes. So, all right. We just want, it asked to find the angular speed in radians per minute. They actually gave us the angular speed. Here, write this down. The angular speed is 33 1/3 revolutions per minute. So that is the angular speed. It's just not the right units. So we want to convert to radians. So there's 2 pi radians per revolution, yes? Which means that's all we need to do to get the units right. I want you to go and type this in. It says round to the nearest tenth. But be careful. You're not going to use 33.3. What I want you to do is type in like 33 plus a third first. Or type in 1 divided by 3 and then add 33 to it. But get that as a decimal. And then times 2 pi. Let's see. You need to avoid rounding errors. And we get 209.4 radians per minute. Now, look at what I wrote. I said radians per minute, but you don't actually write radians. It's unitless, right? So that's your angular velocity, or angular speed, I should say. Yes? All right, so we're done with essentially part A. Now we'll do the next part. Now it just wants us to find the linear speed. Okay? Same situation. And by the way, the distance was irrelevant on the angular part, but now it matters. So once again, linear speed is distance traveled per time, but it's also, and actually I'm just going to write out kind of the derivation again. That means you can do it like that, but really it just means you do the angular speed times r. That's all we need to do since we already know the angular speed. Yes? So, the radius is 30. The angular speed is 209.4. You can see. You got me quickly at that one. That's good. So that's 15 centimeters for the radius times 209.4 radians per minute. So 209.4 times 15 gives us around 3,141.6 centimeters per minute. And that's your linear speed. But it's not the answer we're seeking. Why? They changed it to per second. So, I don't know why. If they're going to do per second, they should have done that here, I think, but they didn't. So, it's not hard though. 1 minute, equivalent to 60 seconds, obviously. But look, I would write it this way. Put the units in there so you can see. This cancels correctly. You get centimeters per second like you should, so it's divided by 60. And notice once again, like you should not have typed in 209.4 times 15. You should have had the 209.4, the unrounded version here in the calculator. So here you're not dividing what I wrote here by 60. You did that last answer divided by 60. If you're not using the calculator that way, you're going to get a different answer than I did. Slightly different. So 52.4, if you're now rounding those tenths, centimeters per second. Here we go. Questions? Then you try it. Okay, they essentially gave you the angular speed, which you can convert it to radians per minute. And I've got it backwards. Just look up here. First of all, once again, you just take the revolutions per minute times 2 pi per revolution. You get that many radians per minute. We're even going to go for the decimal answer. And if I go back to here, this is 2 pi, which is 6.28. 6.28 times 10 is this answer. What I'm getting at, though, is you really want to have this in the calculator. So 10 times 2 pi works out to 62.83 something, okay? So I'm saying, once again, I had this sit in the calculator, on the paper, but I'm not using that, I'm using this. And then I multiply by what? 3, the radius is 3 feet, actually. Put the units on there. And then, so that times 3, the calculator, gives you 188.5 feet per minute. And once again, if they wanted so many feet per hour, so many feet per second, you could change it, but we'll just leave it as feet per minute. All right, now we'll switch over to the next thing. Everyone ready? Once again, this is a new formula. Check, you're supposed to memorize it, okay? And like before, the angles has to be in radians for this formula to work. To check it, plug in 2 pi. And if you let theta be 2 pi for the whole circle, then the 2's cancel and you just get pi r squared, which is the correct formula for a whole circle, right? So I'm just saying, that's just to make sure you memorize the formula correctly. All right, this is not hard. The first example, we're going to use that formula. So it's 1/2 r squared theta is the formula. Since you have fractions here, I would make everything look like a fraction. So you're doing r squared, that's 5 squared, but put it up there like that, like it's a numerator. And then theta is expressed as a fraction. You see how I'm saying? You just line it all up like that, it's not bad. What is 5 squared times 3? 25 times 3 is 75 pi over 8. And nothing was, I would have canceled, but nothing does. And we're just going to leave it in exact form, okay? You can type in the calculator if you want, but we'll just leave it like that. What are the units? It's area, so it's square meters or meters squared. Okay? Now, one thing I want to mention, and let me go back to here, the arc length problems, okay? So, what I'm getting, especially right here, 125 is kind of an unwieldy angle. For this, we use the formula. This is the formula for arc length. Of course, we had to convert this to radians first. My point is, though, you don't need the formula all the time. So if I change this from 125 to 120, That's really easy. 120 degrees is what part of a circle? A third, because 360, right? 12 goes into 36 3 times. You should realize that. It's a third. So this was arc length. What is the circumference of the circle if that's the radius? 2 pi r, 14 pi. Good job, right? Take a third of that. That means the answer is 14 pi over 3, and you're done. Let's take the same circle and say the angle wasn't 120 but rather 90. And so the circumference is 14 pi in the circle. So now the answer is 14 pi over 4 because we're talking about a fourth of a circle, right? If it's 180, well, that's easy. Just take half. Anything that goes into 36 is nice. So like 30 degrees is nice. 40 degrees is just a ninth of a circle. 60 degrees is what part? A sixth? So that's what I'm saying. These problems, you can use the formulas every time you want to. But if the angles are nice, I wouldn't. And so the next example, on going back to the area of a sector, is 60 degrees. I'm doing without a formula. What is the total area on the circle? Pi r squared gives you 64 pi. So the answer of the question, which is what is the area of this part, is just a sixth of that. So it's 64 pi over 6, which simplifies to 33 pi over 3. Hold on 1 second. And that's square feet. Because the area of a circle is pi r squared. And so you just do 8 squared times pi, boom, you have the area of the whole circle. And then, once again, 60 out of 360 is a sixth. So I just took a sixth. Done. Now I'm going to redo the problem using the formula. So once again, the formula looks like this. 1/2 r squared theta, except I can't use 60 degrees. You have to express 60 degrees in radians. So I multiplied by what? Pi over 180 or 180 over pi? So the degrees cancel. And you just get a third pi. You divide, you get 3, so pi over 3. So here, let me set it up. So you have 1/2, put r squared in the numerator like that, times pi over 3. Isn't that the same exact thing? 8 squared pi gives you 64 pi over 6, and you simplify. Okay, so you can use the formula. And here it wasn't bad, but you can also just kind of do it in your head. Weird